So here's the video recording for the question 3 for homework 1, problem 3. So the question would be, there is a digital signal transmitter which transmits 1 or 0 on different probabilities, and there is a receiver on the other end receiving digital signals as zeros and ones, but also with another different kind of probability. To illustrate the problem, so here's we did the drawing. So from the left side is the transmitter and the right side would be the receiver. Okay, so the transmitter transmits the signals zeros at a probability of 0.6. We shall denote this probability as P transmitter 1, and the probability equals to 0.6, and the transmitter transmits signal as 1 at a probability of 0.4, and we also denote this as PT2 equals to 0.4, and as we can see, these two probabilities adds up as to be 1, which is the total probability of the transmitter transmitting signals. And for the receiver, the probability of receiving zeros and ones is dependent on whether the transmitter transmits zero signals or one signals. So when the transmitter transmits zero signals, the receiver receives the signal as a zero at a probability of 0.6. 0.7, sorry. And so let's denote this probability as P receiver 0, 0, 0, 0, 1. Okay, and this is equal to 0.7. And the receiver receives the signal as 1 when the transmitter transmits 0 is at the probability of 0.3, and we denote this as PR02 equals to 0.3, and these two probabilities also adds up to 1. And we draw the pictures as following. So when the transmitter transmits the signals as 1, there are also two other probabilities the receiver might receive. When the receiver receives the signals as 0, the probability is 0.2, and we denote it as PR11 equals to 0.2. And when the transmitter transmits 1 and the receiver receives as 1, the probability is equal to 0.8. And similarly, this probability equals to 0.8. So we have illustrated the problem, and so here's what we're going to find for this problem. The first thing to find is to find the probability data, that data 0, or probability that data 0 is received. So the probability the receiver receives the signals as 0 includes two different situations. One is the transmitter transmits 0, and it receives the same exact correct signal as 0. And the other situation is when the transmitter transmits 1 signals, but the receiver receives differently as a wrong signal as 0. So to calculate this, we denote this maybe as P1. It is equal to, when the transmitter transmits 0, it is PT1 times the probability that it receives the correct signal, which should be PR01. And the second situation would be when the transmitter transmits 1, PT2 times the receiver. It should be PR11, and the result is 0.6 times 0.7 plus 0.4 times 0.2. It equals to 0.5. So for the second problem, we ought to calculate the error of the transmitter and receiver, which includes two different situations. So we to know the probability of the error as P2, and it should be equal to when the transmitter transmits 0 signals but the receiver receives 1 signals. So it should be the probability of the transmitter transmitting 0 signals, which is PT1, times the probability of the receiver receives a different signal, which is PR02. And the second situation is when the transmitter transmits signal once, and it is PT2 times the probability of the receiver receives the different signals as zeros. It should be PR11. And the values for these probabilities are as follows: 0.6 times 0.3 plus 0.4 times 0.2. And the result is just 0.26. That's the error, probability of the error. Thank you.